Alrighty then. Let's try number four. Working question of the day. I guess what's going on? Memes here. Yes, we are back for the fourth session of the day. I don't know if we're going to be getting to the five sessions. We might have to retire a little bit earlier, and or some folks from the summer school might be going out to the bars, as we call them in Boston. So we might do that. Rumor has it even Professor Wolfram may potentially roam around. Again, he's a drinker of water. Why? Because it works for him. And obviously, something's been working for him. So let's not ruin a good thing. But all right, we're on to the candela now. All right. Apologies. Had to grab some lunch, do some stuff and things, chat with some folks, and back to action. All right. So now that we have, okay, let's share our screen. All right, go back up here. All right. We get our little ultimate battle. We got Son Goku and in the literal corner over here. And all right, let's swap over. That's about an hour tune, so let's jump right into it, my friends. All right, let's pick up with the Candela. All right, notebook there, and Candela's here. All right, for the history, da da da. All right, the Candela. Let's see what's new. All right, okay. So again. These units, the SI redefinition is supposed to be based on constants in nature, as we can see for stuff like, to be fair, the meter's got crazy amounts of stuff there. That's the expression of length, but then you have all this deploy on the kilogram to second thing for the Kelvin. The mole, again, I am of the opinion we can count. I'm not saying it's not useful for chemistry, but with the redefinition, they kind of seem to have broken the mole. I don't know. I don't know. Personally, a wise man once said, we can count. I personally don't think it's necessary for our SI base unit system and the Candela. Oh God, this may be quite problematic. All right, let's get into it. Let's see. What's the best way to begin this in a way that here? All right. Okay. Maybe we should. No, I think that's making it worse. All right, so let's just go here. All right. The candela, vision, is perhaps the most powerful of human senses, and light one of humanity's age-old metaphors for understanding, wisdom, and truth. Small wonder then that even in our technological society, the measurement unit for light, the candela, is the most human-oriented of the international system of units. I thought that I'm gonna stop talking. We're gonna read. I'm gonna get through this and hopefully not take as long as temperature on the mole. All right. The candela is SI's base unit for photometry, the science of measuring light as perceived by the human visual system. It is as notable for what it does not do as for what it does. It does not represent the entire amount of light shining from an object. We have a different unit called the lumen for that. But isn't it in lumens? Continue. I'm sorry. It is not used for every kind of electromagnetic radiation. Radio waves, X-rays, and other types of light our eyes cannot detect are measured in watts of power. So, the candela, in particular, is particular. It measures light we can see coming directly from a source we can see straight into our eyes. Its name is a Latin word for candle. And from our earliest attempts to create a measurement unit, we have always reached back to this familiar and ancient light source as is easily grasped reference for brightness, which modern scientists refer to as intensity. But although the candle is, our need for the candela has been driven largely by modern commerce, the creation of incandescent lamps. Less than 150 years ago, up through our contemporary LEDs and smartphone screens have demanded a means to describe how intense these artificial light sources would appear to the humans who use them. We have learned about visible light as light scientists to create specific terms, both verbal and mathematical, to describe ideas of bright. And that we have learned about the human eye continues to form in this effort to measure light's effect on it. We are more sensitive to some colors than to others, and this sensitivity changes as day falls into night and as youth gives way to age. How eloquent. Manufacturers need not take these ideas into account as they design virtually every lighting product on the market, tasked to release back to the candela. The oddity of the SI, the sole unit that remains tied to human perception. We didn't update anything on it. I'm, I'm sorry. I'm sorry. It's just spherical cal. Okay. The candela is a unit, according to Wolfram Alpha. Okay. So its conversion from other units is precisely one English sperm candle. It is still literally a candle. Okay. Okay. It's luminous intensity. Okay. Then you go to luminous intensity. Okay. Luminous intensity, candela. Okay, is it in the lumens? Lumen. It's expressed in spherical candle power. It- we have a unit for that. Yes. It's still referencing the candela. The candela, it just except it's projecting like a if you were to have like a sphere. So it's in radians squared, which I believe that's steradians. Hold on. Radians squared. Square radian. Yeah, it's a steradian. So like if you had a solid angle of stuff. I digress. I digress. It's okay. Let's continue, my friends. All right. All right. Among the definitive early achievements in human development is our mastery of fire. Flame was our first source of artificial light. It remains essentially our only source, even in 1875, when the National Bureau of Weights and Measures, BIPM, was created to help nations agree on standard measurement units. Definition of luminescence alluded us to that point. Today, we describe it as candelas per square meter, but the idea of relative brightness reaches back to early astronomers. The apparent magnitude scale we use for comparing brightness of stars built on ancient Greek system, refined and codified in 1856, what we would recognize as modern photometry stretches back to 1729 when French scientist Pierre Bourgeois made measurements determining the light of the sun to be 300 times more intense than that of the moon. That's impressive. Somebody that stared at the sun, don't recommend it. Unifying these historic efforts was the idea that these smaller point-like sources of light made different impressions of intensity on the human eye. Agreed upon units for intensity were far off, however. Different nations eventually came up with their own ways to specify how bright a light source was. All of them based on a defined way of creating a flame, and many making reference to a familiar source, a candle. The ways of making a candle can vary from the size of the wick to the type of wax used. French physicist Jules Violet, oh, that's one of the units in there, attempted to sidestep these issues in 1879 by heating platinum to its melting point of 1770 degrees Celsius, 3220 Fahrenheit, tying luminosity to the metal's glow. Violet was ahead of his time, though his idea was difficult to reproduce in practice using 19th century methods. Scientists would soon return to elements of it as artificial lighting was about to become widespread. Photometry progressed far more rapidly with the inventions of the incandescent lamp and the gas mantle. These inventions were widely adopted, and the public needed a standard measurement to understand how intense they were. Okay, blah, blah, blah. A group of carbon filament lamps. Hefner flame. Oh, okay. National laboratories, blah, blah, blah. Okay, international. Lumens intensity in these four countries, the culminating adoption in 1909 of the International Candle as a unit in England, France, and the United States, with the Hefner candle of Germany considered as zero point 0.9 as large as the International Candle. The year 1909, so Great Britain, France agreeing on a standard candle built from carbon filaments, which scientific communities soon realized had stability problems. Okay. Hmm. Pardon. I had to caffeinate myself. I'm also apparently now it's going through my AirPods, so I don't know. A lot of times it doesn't like to work. I think people can hear. It's at least doing the little thingy there and saying there. Sometimes it does, sometimes it doesn't. Why? Gremlins? I don't know. I continue. Eventually, the idea of using a black body, a perfect absorber and emitter of light, took hold as a solution. While such an idealized material does not exist in nature, scientists approximate it closely using platinum coated with iron oxide, which acts nearly like a black body. In 1933, the scientific community agreed to develop units based on luminous intensity, essentially the power emitted by a light in a particular direction of a black body at platinum's melting point. Oh, okay. Cool. Okay. 500 watt. Ooh, that's a bright one. A gas-filled incandescent lamp was used. The luminous intensity started in 1970. Okay, so full disclosure, when I was a kid, I can see why they kind of swapped over. Don't get me wrong. The incandescent light bulb goes on filament, it starts to heat up the glass surrounding it. So there was a franchise called Dino Riders, and one of the villains was Krulos. And I remember taking a little Krulos action figure, putting it on top of a lamp, and literally having it melt through. And an old incandescent light bulb. In retrospect, that probably wasn't safe at all, and probably one of the reasons why they got rid of it because those bulbs get very hot. So just just a little deep lore that doesn't really matter. Let's continue. Okay, so all right, so standard. Okay, so let's see. Magnitudes of brightness. Magnitudes of brightness. Okay, the remaining only source in. Okay. Uh, let's see. Let's go through the history here. What do we? French Cyberheen Platinum. Okay. Okay. So lit literally based on a candle. Hence the name. Uh, what'd they say? Latin and based on a candle held the name from Latin. Get a little history in there. Modern commerce developed so humans could have a basis for luminous intensity. We could visualize a lot of stuff if we're going to be taking in all the different uh, waves of the spectrum. Well, it's gonna be a little bit different because it's like, what is it? Oh, yeah, now that was they have contact lenses where it's like you can literally see infrared potentially. Now, the level of safeness and efficacy, I cannot say. Um, please consult your optometrist. All right. Okay. The oddity, all right, is is an oddity, so to speak, in SI as it is the only unit directly based on human perception. Okay. Okay. Candela. I don't really even know if there's a new definition to it, to be fair. Among the definitive early achievements of Mastery of Flame. Okay, magnitude scale, brightness of stars, refined. As we describe in candles per square meter, but they reaches back early astronomy. The apparent magnitude. Let's see. Okay, Hipparchus. Oh, and Ptolemy. Okay, so let's see. Oh God, we don't need to. Okay, early. Uh, early attempts to codify uh, luminous intensity, uh, eternally intensity or brightness. Uh, early astronomers attempted to codify luminous intensity or brightness without modern tools of measurement. It was quite hard. Okay, so just reference because hey, if you can reference Ptolemy, it's probably a decent thing. Okay, so let's see. Okay. For instance, both Arcus and Ptolemy used excuse me, categorized stars by uh, let's see, by magnitude, brightness, or magnitude. By magnitude, how about of brightness? That seems I might be just wordsmithing so I don't completely rip it off, but hey, I digress. All right, let's see. Where are we here? Okay. Let us continue. Yes, I'm live streaming on a Saturday night at 8 p.m. Why? Because we can. I gotta get it done at some point. So let's see. Okay. What's the Greek system? Let's see. Oh God. The magnitude scale. Okay. I mean, this is a cool little picture. Oh, I got Galileo. Galileo Galilei strikes again. Okay, give us another source there. Uh, Parcus. Let's add some Parcus and Galileo. Cool. All right. Say, okay, let's do this number four. Save as WSS units project 628 25 4. Thermoscope is not a modern word, I guess. Save early, save often, my friends. All right. Damn, there's a lot on the tangents. Okay. This is only like a page or two there. We can. Okay, that's got references to. That's fine. We can wordsmith. We can tell some tales. All right. So, oh God, we're still going on about the candela. All right. So, by magnitude of brightness. Well, the magnitude scale. Yeah, it's literally the magnitude. Bright star's first magnitude. Okay. The magnitude scale. Uh, it's originally used to classify the brightest. So now we're getting to astronomy. Objects slash stars as first magnitude. Okay, because that's literally a human thing. Because well, if there's a star far away, it's a lot brighter, but it's really, really far. If it was close to the sun, it would probably eat us, fry us, something like that. The stars as first magnitude. And so on. Okay. Okay, when Italian scientist Galileo Galilei turned the telescope to the sky, discovered stars fainter than the faintest stars visible with the naked eye. Since these stars were fainter than Parkinson's faint stars, Galileo called them seventh magnitude. So the stars were large scale that's discovered can okay, and so on up to six magnitude. Galileo uh, discovered via telescope even fainter stars. We continued to add uh, addi- add additional. We'll wordsmith that. Additional magnitudes, such as seventh and higher. Cool. All right. Let's see. Yes. Also, I am also realizing that if you do more than three, videos or live streams of stuff during the day, it also doesn't send out notifications because, well, don't just want to spam folks that much. That's rude. And this is basically for posterity's sake. All right. So, oh, where was that? All right. So much that the magnitude system confused them. They realized they need to give magnitude system a mathematical, so too strong as green and exactly how bright star was. And Fox suggests the star's magnitude would be defined in terms of the star's radiant flux. Fox thinks this mass starts emitting about 100 times as much light, 6 magnitude, and so on. The sky scale increase of 5 magnitude numbers meant uh, a 100-fold increase in radiant flux. By this definition, Vega's magnitude very close to zero, so astronomers choose Vega as a reference point for the magnitude system. Later, astronomers extended the magnitude scale to brighter objects by giving them negative numbers. Today, the magnitude system has been extended so far, there are now 56 magnitudes. Between the brightest thing we see, the sun, which is negative 26, and the farthest objects by the Hubble Space Telescope, 30 plus. Okay, so this was from probably the past 20 years. In terms of the amount of light received by the Earth, the magnitude scales 2.5 up to the 56th. Is that 2.4 times 10 to the 22 factorial? Oh, no, no, no. Okay, no, sorry. Sorry. That's just an exclamation point. I'm just seeing factorials everywhere. The magnitude scale seems arbitrary and confusing, even to astronomers, but the scale gives a precise measurement of the brightness of stars and pays tribute to the 4,000-year-old history of astronomy as a science. Astronomers keep using it. Oh my God. Uh, okay, so where was this? It was Oxen. Okay, okay. As we gained more information, information from the heavens, uh, the scale continued to increase, and in 1856, uh, Norman Hodgson, uh, Oxford astronomer, uh, suggested that we categorize the all right, magnitude based on radiant flux. What is radiant flux? To a physical quantity or radiant power? Oh, okay, so it's literally power. Mass times an area divided by time to the third. Okay, so it's literally power because it's watts. The unit, it's 1 joule per second, so it's energy per second. Okay, groovy. Here's some lumens. Again, I'm kind of dubious. Okay, so let's so today uh the scale has been okay, that's why it's like log 5 or 5 log something. All right. Has been adjusted so the brightest objects have a negative number associated, i.e., the sun is negative 20. This is so confusing. Negative 26 uh, and extremely distant objects are magnitude 30 plus. This scale is quite confusing, even to astronomers. Okay, there we go. All right, let's get back right to it. There we go. Okay. Okay, unifying these historic efforts with the idea that these small point-like saucers are made different impressions of the test the human eye agree upon units that's we're far off, however. Okay. Different nations eventually came up with their own ways. Okay. Jules, VLA, French assist. Ta-da. Tempted to uh, yeah. Uh, heated. Heated platinum to melting point and tried to use that as a measure for brightness. This was quite hard to replicate in the 19th century. Century, uh, but was, I mean, it was ahead of its time. It was quite bold as he was essentially attempting to use a black body as reference. Okay, blah, blah, blah. Okay, let's see. A year. In 1909, uh, the United States, Great Britain, and France agreed on a uh, standard handle using carbon filaments. However, there were stability problems. Okay, imagine. Engineering can be tough. Uh, Okay, I think I extended Viola's argument a little bit too far. Let's see. Uh, okay, we'll just leave it at that. Let's. Okay. Perfect absorbent emitter, which is a black body, took hold of the solution while touching idealized material, denies its nature, approximate closely using platinum coated with iron oxide, nearly acts as a black body. Based on Lumens, potentially assess the power made by a light in a particular direction of a black body at platinum's melting point. Okay. Okay. Viole's idea of using heated platinum made a resurgence in 1933 when the scientific community uh, okay. Let's see. Platinum coated with iron oxide, which acts nearly like a black body based on this potentially the power of a black body at planet's melting point. Okay. Approximate using which next to nice. Okay, essentially the power made by light in a particular black body at platinum's melting point. Okay. Uh, units based on the power of light in a given direction based on uh, based on a black body at a melting point, flat point, flat, and the platinum something developed well, oh wow, I'm so bad at spelling. Wow, I'm so bad. Units based on the melting point uh, on the melting point of platinum uh, uh, the melting point of hell, let me read this again. While such an idealized material does not exist in nature, scientists approximate closely using platinum coated with iron oxide, which acts nearly like a black body. In 1933, the scientific community agreed to develop units based on lumens, essentially the power mid of light in a particular direction of a black body at platinum's melting point. All right. Develop units based on the of, I guess I don't have any other way to say it. A black body at the, edit, undo, based on a black body at the melting point of platinum, uh, generating power, generating power, generating, uh, generating power emitted by light in a given direction. Wow. I mean, I don't know how to say it much more succinctly than that. That's just kind of one of those things where you're like, okay. Okay. In the early 20th century, RFLED became common enough standard unit of light, though it was modern technology that lowly is, and the unit itself referenced the historical brightness of a candle is the human unit made for the human eye. All right. Candle maker of the rest might not understand the wording, but would recognize the brightness of a candle expressed by the first definition of candela from 1948. All right. The luminous intensity in the perpendicular direction of a surface of 1/600,000 square meter of a black body at the temperature of freezing platinum under a pressure of 101,325 newtons per square meter. Because that's obvious, isn't it? Specifying the pressure is important because it affects the temperature at which platinum melts. Okay, I just have to check platinum. At least the mole was like carbon 12. We're like, all right, this kind of makes sense. Platinum. Is there something about platinum that's supposed to be very conductive? It's on number 78. What's it really good for? Solid melting point. Okay, so 17th. Boiling point's the 18th. Let's see some more stuff. Okay. Rank 11th. Let's see. Material properties. Gear modulus. Rank 6th. I I guess that's just what they used. Oh, look, about 10 to the negative 7 ohm meters. Oh, very neat. Paramagnetic. Thresholds. Valence. Guess they just used platinum because, well, they could. Let's continue, my friends. All right. Refinements to the definition of candela came with advances in radiometry, the measurement of optical radiation to accommodate easier methods of creating light that do not rely on platinum artifact. Okay. Okay. So the first official definition came in 1948. Okay, we're just gonna do a quote for this. I'm literally just copying this because that is the luminous intensity in the perpendicular direction of a surface. There's, we just read through that. Wow. Pressure must be included to account for the temperature at that platinum melts. Okay, present refinements to the definition of the candela came with advances in radiography, the measure of optical radiation, to accommodate easier methods of creating light that do not rely on a platinum artifact. But they continue to reference the amount of light a traditional candle would generate. In 1979, the General Conference on Weights and Measures, CGPM, adopted a new definition, the candela, the luminous intensity in a given direction of its source that is monochromatic radiation of a frequency of 540 times 10 to the 12 hertz. There's a radiant intensity in the direction of 683 watt per steradian. Technically, though this language may be, it remains an attempt to match our modern understanding of the human eye with what we still perceive to be a candle's brightness. Okay. 160. What's that again? 683, 683. 683. Is that, hold on. No, that was in, okay, the watch should not be in the denominator. Sorry. Need that. All right. Okay. Okay. And then what was the other part of the definition? 540, 10 to the 12 hertz. All right, so 540 times 10 raised to the 12 hertz. Uh, all right, that's the rate of power. Okay, that's okay. Specify the frequency. All right. Is I think that's literally what it is. Oh God, we've complicated it even more. Ah! All right. All right. 1979. The, the General Conference on Weights and Measures. I think General Conference. Hold on. 1954. All right. Yeah. Hey, go humans. Weights and Measures. Uh, uh, measures created the first modern definition. Okay, I just have to take the quotes for these just because this is okay. So they okay that I don't know. This might be even better. I mean, hey, if you didn't have Wolfram Alpha at the time, that's like what? 10 raised to the 12 hertz. This in here. First Iridian. Uh, Specify the frequency of light, not the. Okay, so we're literally just doing this red. to violet. Infrared, microwaves, ultraviolet, X-rays, gamma rays. Most light bulbs are not green, however. For light of another color in the broad spectrum colors, such as the light from LED bulbs, an intermesh create a method of accounting for the eye's greater sensitivity, akin to the idea of placing lights on. Oh God, more influence to those colors. Taking into account each color's respective influence gives you the light's overall. Oh my God! Speaking of intensity, there are two distinct references to it in the definition: luminous intensity and radiant intensity. This distinction relates to human perception as well. While radiant intensity is the intensity of light without justice for human vision, luminous intensity is the photometric unit that compensates for human visual sensitivity. To convey the idea of light radiating into three-dimensional space, scientists employ the idea of a solid angle. Oh, steradian. Imagine my shock. Where a two-dimensional flat angle carved out of a piece of a circle, looking like a slice of pie. A three-dimensional solid angle is a section of a sphere, shaped like a cone. This three-dimensional angle stretching out from the center of the surface is measured in steradians, the unit of solid angle. If you had a sphere is raised with 1 meter, a 1 steradian section would be a circle marking out an area of 1 square meter of its surface. Regardless of size, the solid angle of a sphere is 4 pi steradians. That makes sense to me. Okay. Utilizing solid angles as part of the candela definition specifies light that shines in a particular direction. When you purchase a light bulb, its brightness is given non-candelas, but in lumens, which tells you how much light it puts out in total. Telling you it's a brightness in all directions. Okay. Okay. Note that the candela is light in a given direction, while lumens is total light emitted, given our previous definitions, caveats. Cool. All right. This understanding of the human vision has led to the creation of one of 7 defining constants, SI basics. The constant K sub CD is the candela is equal to 683 lumens per watt. A value makes the modern candela roughly equivalent to the previous defined candela. Roughly speaking, 1 over 683 watts per steradian. It's the amount of power needed to generate a candle's brightness. This value not tied to any particular fundamental physical effect separate from human perception any more than the previous definitions. Okay. Uh, hold on. Not tied to any fundamental physical effect separate from human perception. All right, I'm just physical effects separate from human perception. Okay. Okay, I need to add another quote. Literally eyeballing it. Again, useful. Mold, useful. Gambilas, useful. Fundamental? Eh. All of the potential in human sense is striking when the candela is compared with other fundamental concepts, many of others, such as speed of light in a vacuum or the charge and electron properties of the universe. The candela is universal in that it is green everywhere in the cosmos, but to an alien or a creature from our our planet's different visual sensory selection as a definitive concept would seem highly arbitrary. It's simply convenient for human perception. The mantis shrimp would have words with us. I think it's got the best vision. It's got like, I don't know, 14 different color cones or something. I remember different folks saying stuff like that. So, yes, Rick. Yes, it's here's the thing. After like three updates and everything, yeah, it stopped sending out notifications. I remember that because that even happened to Team Wolfram at one point. There were a bunch of live streams and then a bunch of folks didn't get notifications. But yes, we are yes, we're going through the is it just me or the things that I have more of an issue with I'm writing a lot more about? Like the mole we went on. Oh, the candela. Oh, it's a freaking again, maybe there's something fundamental, but it's like you look at the original definition, okay. The first official definition in 1948. The luminous intensity in the perpendicular direction of a surface of 1/600,000th square meter of a black body at the temperature of freezing platinum under a pressure of 101,325 newtons per square meter. Obviously, about the magnitude of one candle. 79, they instituted the 540 times 10 to the 12 hertz, and then they're usually steradians, though. So I mean that they got that. I am very dubious about this. It's again, I feel like the mantis shrimp would have words with us. So all right, okay, blah 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 blah. All right, where was that? Okay, now we get to the new definition. As of May 20th, 2019, the definition of the candela has changed to a far more complicated wording than the 1979 definition. The actual value of the candela will not appreciably change, though it is tied to the other SI units, which in some cases have been redefined themselves. There will be an imperceptible difference. The language of the candela's definition now primarily aimed at technical experts. All right. Oh, God. Okay, I'm literally just copying and pasting this quote. All right. No. The candela is defined by taking the fixed numerical value of the luminous efficacy of monochromatic radiation of frequency 540 times 10 to the 12 hertz candela to be 683 when expressed in the unit lumens times times watts to the negative 1, which is equal to candela times teridians times watts to the negative 1, or candela times teridians times kilograms to the negative 1, uh, times, all right, hold on, times meters to the negative 2, and then seconds. They inverted that because it's kilograms area divide by seconds to the third. Okay, so hold on. That's oh God. Yes. They weren't kidding when they said it got more confusing. All right, so all right. Kilograms. Oh yeah, meters, seconds. Okay, hold on. So okay. So 680. Okay, so rather than doing 1 over 683, they're just to be 683 when expressed in lumens divided by watts, okay, which is equal to candela times teridians divided by watts, or candela times teridians divided by kilograms, meters, and then seconds. Divided by kilograms and meters squared times seconds to the third. Where 1 kilogram meter seconds are defined in terms of Planck's constant, the speed of light, and the hyperfine transition cesium 133 is now linked closely with the other units and constants in the new SI. One candela light source, though, will still appear to the human eye as bright as the wax candle of yesteryear. Reducing the uncertainty when measuring units intensity. We can measure the second to an accuracy of a billionth of a second with the candela, not even within one part of in 1,000, aka 0.1%. Reducing this will not alter the definition, but is important because the lighting and design changes to translate by better night size and to improve our measure of how each visible wavelength. The recent measuring, blah, 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 allowed scientists to take response to a slice spectrum of 2 times wide, so 2 nanometers, but uncertainty is the bane of measurement science. Increases its life. Okay. Uh, yeah. Okay. Issues persist as this is still a human based unit, as a human perception. These are basically all human units, so we want to be specified. Still a human perception based unit of which, depending on time of day, amount of other light present, and color of the light, all have perception based influence. Okay, so I think as Mr. Horse said in Ren and Stimpy, no sir, I don't like it. Now again, that's too harsh. That is too harsh. It's again, like the mole, useful, fundamental. Again, as we started off, I wise man once said, we can count. I don't think it, at least within the scope and course of Wolfram physics, I don't think we need the mole. I don't think we need the candela. I'm pretty sure we could do it with five. Again, I'm very biased in that. I'm also going to lobby that rather than going with the ampere or current, I'm going to say charge might be a better thing to do. Because also, Dugan, it's like, well, hey, can we get a notion for the fine structure constant in our hypergraphs? It's like I took that and I thought I'm like, to be fair, if you just use the colloquial definition, it's just elementary charge squared over the yada yada. Long story short, you just reduce it. It's literally elementary charge divided by the Planck charge. You square the whole thing, or you don't square it, and you get the fine structure constant's amplitude, or basically the way Professor Feynman liked to think about the fine structure constant. I don't know. Maybe 1 over 11.7 isn't quite as sexy, so to speak, as 1 over 137. Uh, hey, we don't like some primes. Okay. Oh, yes. And also, literally, what is it? The ampere. Uh, it's literally defined by elementary charge. They're literally defining it by charge. I'm just saying. Okay, I could go a lot more into these other ones. Wow. Okay, I'm gonna have to go a lot more into those because, okay, this is probably the detail I actually needed. I didn't just want to copy Wikipedia because that seemed ill posed and I should go to the other things. But hey, if I'm getting it literally from NIST, that sounds like a source to me. They're the people literally setting the measurements. Hey, and then they occasionally have blast from the past, like this little link here. Oh God, this is probably done from like 20 or so years ago, back when web pages were all funky and we just did all this little quick and easy. All right. Hey, Sandra. Yeah, I apologize, man. I've been driving across country, driving through a country, visiting folks across the United States, Canada, popping over to Portugal for the Visticon 2025. Had a blast over there, and now literally got back. And whilst I was on the plane, week zero of the Wolfram summer school physics track started. I paid the $5 for the Delta Wi-Fi. It has Zoom blocked. It wouldn't let me on. So I eventually joined up there. So was it 2 weeks ago we had week zero of the Wolfram Physics Project. So a bunch of classes there. Now we're actually on campus down at in Waltham at Bentley University. I have some dorms and stuff over there. I've just been commuting most of the time just because I live like half an hour away. And it's nice to actually get sleep and not be a zombie. Uh, but yeah, now I'm channeling my inner Professor Wolfram and just live streaming these sessions. Why? Because well, if he can do it for 6 hours, like no interaction, just uploading it, because he's a science guy. He likes to look at the science in the way he finds most useful to himself. Oh, I can at least do my summer school project there. And hey, maybe if somebody can get something out of this, cool. Just see how it's done. And I mean, literally, this is just history and stuff right now. So I need to finish this by at least tomorrow, or at least the main bulk of it, actually put it into a coherent form, add little snippets of general calculational code. Uh, so then next week we can actually dive into trying to find out interesting things. Am I expecting to find the energy of a single causal edge in a hypergraph? No. I'm I'm planning for basically a null result because I mean, what are the chances you could find something fundamental like that in like a week? I mean, it would be cool, but I can't rule it out. It's computationally irreducible, I claim. Most likely scenario, no result. We search in space. We don't find anything cool. Hey, here are the results we have. If they're not impressive, we'll just set up for future work for next year or another time. It would be cool to find something, but I'm not going to plan on it. But hey, I'm going to have a whole bunch of folks to help me and maybe even bring in a couple of folks. Maybe from the monastery. We'll see how things go, and perhaps we'll have some correspondence with the institute and a few other folks, and folks can just kind of go into units and why maybe some units might be better for others, and see if we can find some Wolfram physics related type stuff and things. So, okay, did we finish with the candela? Okay, I think so. Oh God, that was a lot. I apologize. All right, so Dave, hold on, Dave. Oh, ringer, so to speak. Now, I'm not going to say no. Ringers in the most polite type of way, just simply just keeping calm, cool, collected, and just giving a little bit of input here. Sometimes saying less it can say a lot more. That's what I found because a lot of times I wanted to say all these things and I'm like, no, no, hold your tongue, and just occasionally wait, and kind of do the whole game that Professor Feynman had with Stephen Wolfram, where it's like you wait to the opportune moment to make the most impactful comment possible. Where, especially if the conversation's gone a particular way, all of a sudden people like, oh, I had not considered that. I never read Jack Kemp's book that was supposed to winning hearts and minds or friends and allies and stuff like that. I was supposed to. I went home and played World of Warcraft Full disclosure, he actually was giving a talk at my alma mater at one point. I skipped it. Uh yeah, so it took me like another 20 years to kind of figure that stuff out. But yes, yes. I know Jax. I know Jax. I need to calm myself. All right. Save in all relevant forms. So let's save there. Okay, I'm actually gonna save this as fifth version. Units project 628 25 fifth version. Let's save that again. All right, and now we're gonna save to the cloud. Okay, save. All right. So hopefully the plan will be I might be out late tonight, and then I think 1 p.m. I have the Demystify Psi Sunday call, so I'll try to pop on for that. And then just repeat all this tomorrow and just see if we can't. I'm going to need to flesh out some of these other things. I'm just looking at this. I'm like, all right, so we had that for temperature, all this stuff for the mole. Oh, God. I obviously ragged on the candela a lot. I'm like, okay, I need more for this. This is not adequate. What the heck am I doing? Let's go through the full history. And basically, I'm just going to use mostly NIST as the source, and then we'll go through the other sources. If anybody has any direct recommendations, particular links, feel free to send them my way. Email, comments down below. Uh, Feel free. Okay. But as of now, my brain is kind of fried, and I might go have a little bit of libation with some of the crew. So, other than that, y'all have a great Saturday evening, morning, afternoon, wherever you might be. Uh, yeah. Hey, well, I try to fight for reality. I'm gonna stop talking because I'm gonna get myself in more trouble. So, okay, I did save everything. Close. All right. With that all, peace out, everybody. Take care of yourselves. It's a wacky and wild world out there, but yeah, it's open for a better tomorrow. Take care.